It's very important to understand the justification and driver for moving from an on-premise infrastructure into cloud. Certainly, most cloud providers will try and promote the cost savings and ROI of moving into a cloud data center. This may involve running costs around infrastructure, potentially the purchase of servers, the real estate, or the security of that real estate, or any of the ongoing maintenance costs that you may have around electricity or even around people and labor. But from my discussion with a lot of customers, it's actually quite expensive to do a straight out lift and shift from on-premise to cloud, and not necessarily any beneficial. So I often try and promote the adoption of foundational cloud techniques. And one of them I want to talk about with you today is around serverless computing. So what is serverless computing? Well, as per the Red Hat public website, it is a cloud-native development model that allows developers to build, run apps without having to manage the servers behind them. There are still servers in the background, of course, but we abstract them away from the development mindset, allowing them to just package their code, write their code, and focus on their development exercises. Certainly, in most instances, from what I've seen, the developers care mostly for the platform they're on, be it Java, Quarkus, Python, Go, .NET, as well as any middleware or plugins they need. But assuming they have that, I notice they don't really seem to care as much around the patching cycles or the patching versions or even the operating system, as long as the platform and the workspace that they have is working as needed. Openshift does handle the routine work of provisioning, maintaining, and scaling any of the server infrastructure. And so once deployed, serverless apps do respond to the demand automatically, scaling up and down as needed. But we take a lot of those activities away from the development mindset.
But here's the fact. I'm the only one of these clowns that can code in Java. And I write sleek, performant, low-overhead Scala code with higher-order functions that will run on anything. Period. End of sentence.
So, in short, serverless is infrastructure agnostic. But as I said before, there are servers running in the background. It runs on something called a FaaS model, and FaaS is short for Function as a Service. In the FaaS world, think of writing more smaller units of code, units of work, and it's designed in the mindset and thinking of SOC, separation of concern. And the reason why we do this is because we want to containerize our functions on a unit level, making them much smaller to manage. You certainly don't want to be managing functions that are 3 or 4 gig in size, massive containers. We try not to keep our containers big, we try and keep them small in size. There may be more of them, but they are much easier to manage. And finally, as I said before, they're actually event-driven. And they're event-driven in a way that it creates a trigger which allows Openshift to know when an actual function is being accessed. And this is important from the pay-as-you-go mindset. And the reason why I want to talk about the pay-as-you-go mindset, and I'm going to use an analogy here, is around boiling water. How often do you need continuous instant boiling water? In most cases, in the households, you may not. When you need water, when you want a cup of coffee or a cup of tea, you boil water on a kettle. Larger organizations will probably use an urn, and they will have continuous instant boiling water. But in both cases, it depends on desire and need of when and how you want it. And this is the flexibility that comes out of serverless computing. You pay for a function as you use it and only when you use it. So I'd like to just go through today and give you guys a quick demo around how to actually get started with serverless. We're going to follow 3 different steps here. The first is to write the function, and we'll be using Knative and the Knative CLI behind this. I'll show you this in a moment. We'll be building our function. As I said before, our functions will all get containerized, and from there we'll actually be using Podman, and I'm very excited to say we'll be using Podman version 5. And then finally we'll be deploying our function. And there are many places that you can deploy our function, but I'll actually be using Openshift on AWS Rosa. So let's get into it. So we're in our little micro development environment here, and you'll see that I have 2 windows open. On the left I actually have a terminal, and from the terminal I'll actually be executing from the Knative CLI. It is known as KN. You can download it from knative.dev. KN is the CLI, and this is where I'll be executing a lot of my serverless commands. And then on the right I have an IDE. I'm using VS Code for this demo, but you can use any IDE that you want. So as I said, from the left is where I'll actually be using KN. So if I type this in, and you'll see here, you can get it from knative.dev. And this is quite comprehensive. You'll see here that we have serving and eventing commands from a top level to go ahead and manage a lot of your functions. But what there is also in here, which is pretty cool, is a little plugin called Func. And you can actually download this on top of KA, and then in there you can actually use it to help build and manage and deploy functions. It actually writes some sample boilerplate code that you can use to sort of help kick you off. And I can expose this by typing in func or kn-func. For consistency, I'll go with kn-func. And you'll see in here that there's a whole bunch of subcommands that I can now run under kn-func. So the ones that I said, and we'll keep it consistent with the PowerPoint, is we'll run create, we'll run build, and we'll run deploy. Right, the big three that we will go ahead and work on. So if I look at firstly at create, you'll see that I'm doing a help on the languages available, just so you guys can see. So there's Go, there's Node, there's Python, Quarkus, Rust, Spring Boot, TypeScript, straight out of the box vanilla. You can add languages on top of that, but you'd have to do a little bit of a workaround, but straight out of the box are these here. So let's go ahead and create a function. So I'm going to pick a language. I'll pick one randomly. Let's go with Node, and we'll give it a name. So I've done this, and you'll see it's created a new function inside this folder here. So going into my Red Hat folder here, you'll see that I now have a subfolder, which I'll go into, and in here you'll see that I have a package.json and index.js, very simple Node.js app. And in there is just that one function. As I mentioned before, we're trying to keep our functions, especially serverless functions, we try and keep them on a unit level to keep the containers a little smaller. So now going into my IDE, if I actually open this up, let's have a look at it. Launch Teams. Going in here, you'll see that there is a func YAML, which is typically there to help with the deployment of the serverless function into Openshift, and this will actually build as time goes on. You'll see a lot more stuff being populated into this. The package.json, it's very simple right now. I'm not really running too many node-dependent modules, just the faz.js runtime. And then inside it, the function itself is quite simple. All it does is it handles a HTTP request. And it captures the context, the HTTP context, or the body information inside the HTTP. And then depending on what the request's verb is, so the HTTP verb is, if it's post, it'll just return whatever's in the body. If it's get, it'll actually return the context query. Right? So a really simple function which kn-func will build for you just quickly out of the box, so you can just get it set up. And you could actually override this and just put your stuff in here, or the boilerplate stuff is built, or you can just go ahead and create your own function. But to actually compile this now, so the next step is to actually build this, and we're actually going to build this into a container. And for that, I will actually open up Podman Desktop here, and you'll see that I'm running Podman version 5, and I'm running this on OS X. There is an OpenShift local instance here that I'm not running because I wanted to show you this running on AWS. But if you really have problems with cloud or internet connectivity, or you want to just do everything local, you can run OpenShift local now via Podman, which is awesome as well. But for now, we'll actually be moving it to AWS, and I will be doing it via Podman 5. So going into here, and we will. Func build. We'll run the command kn-func build, and what this does is it actually tries to build and create a container. Now, just to save ahead of time here, I've actually gone ahead and pre-downloaded a lot of the layers that are in here, so this should take a bit longer. So typically now, because we're using Node.js, it uses the default UBI from Red Hat, and you'll see in here it's actually built it quite quickly. So the image itself is down here. It's 319 meg. So nice and quick, and we now have a containerized version of that function. To actually test the function, we can actually do kn-func run. And so you'll see in here that very quickly it is now running on host port 8080. So if I go to a browser or an API tool, and I will actually go to an API tool, I'll actually go to Postman. And in Postman, I'll actually go to my local host. And in here, I'll just send some values. So value 1, and we'll return back kn-func command. Alright, so I'm just putting in some dummy values in here. So this is the second value. Alright, so nothing special, but if I actually hit send, you'll see here that it's actually, because this is a GET request, it's actually returning back the context query, which were the two values that I've got in here. On the left, you can also see that the command line that I'm running kn func run on, because this is already running in the container, has already received those requests, and it's actually outputting information about it. So from here, we actually know that the code is working, which is good to know. Okay. So that being said, let's break out of our running mode and let's actually try and deploy this.
What is he doing?
He's beginning to believe.
To deploy this, I mentioned earlier that I'll be pushing this to AWS into a Rosa instance. We have a cluster running that I've got going, which I can show you right now. And here it is here. I'm in the administrator view, and you can see that it's just a very simple looking cluster. And so what I'll do is I'll actually go into the projects, and I did create a project ahead of time called Launch Teams. So we'll just go in here. So I'm actually in this project here. We'll switch to the developer view so you guys can actually see this thing being built. So in here right now, there's absolutely nothing available. So to actually push to my AWS instance, all I do is kn func deploy. Very simple command. So right now it's forcing the build, and you'll see it's immediately detected this on the cluster, because right now it's trying to push. We will be pushing the image to the registry, so that container will actually get pushed up, and we're using the default Openshift credentials. So let's give this a second, and you'll see in here that it is running the in-cluster dialer. So just going into details, there's a pod there available. So it's running the build. As always, the first time load takes a little bit longer. So now it's deploying the function. And you'll see I get the big check saying that it is working. So this is awesome. So now we have our Node.js function in there. It's running on one pod. Okay, so that's great. And if I have a look in here now under the resources, you'll see that it's also created the route for me, and this is the route that I'll actually be using to expose to it. So if I actually copy this, let's move this over to my left, and we will open up Postman again. Okay, so this time in Postman I'll be using that URL, and I'll be sending value 1 again and value 2. Oops. Sent to the instance, and then value 2, which will be, this is the second value. So you'll see here right now what's happened is, because I wasn't using the function, I've actually scaled down to 0. However, as soon as I send a new request, and this is where the boiling water analogy comes in, I need to now call this function. I click send. It actually discovers that there's an event. The event says there's a new request, and it'll actually spin up a pod, and you'll see in here that it's already given me the response. And this is the power of serverless functions. They only get triggered when you need them. So if you're calling a function once a day, you don't need your infrastructure running 24/7. You can just let it sit there, and then as soon as the event is detected, it'll spin up the pod. Likewise, you can go the other route where you have something that is very heavily hit, where you can actually, determine the resource quotas for it and decide which way you want it to go. But if we give it a second, this should spin down again because there's no activity, and it'll go back to 0. And as soon as it does, I'll show it to you again, just to verify that it is actually spooling up and down properly. So let's just give it a moment. I think it's typically 60 seconds. You can set the value of the timeout here, but it's typically, I think, 60 seconds. So we'll give it a moment to spin back down. That's taking its sweet time. It's gone back to 0 now. So let's hit the request again. The request is a little bit slower as it spools up. So as always, the first time load is a little bit slower, but it's actually created a pod. We've got one running. Now, the next time I run this, and I can change my values here. The second value again, and you'll see that as I run this, You'll see how fast it is. It's definitely working because the context is changing. It's actually running very quickly once it's spooled up. So that first time load is always just that slight bit slower. But there you go. This is an example of how serverless operations can greatly benefit your business.